Then I created negative 8x plus 4y plus 28, moving 28 to the other side, and 4x minus 4y equals 4, moving 4 to the other side. Is that okay?
Yes.
Okay, now let's see what I did next. Here I divided both sides by 4. Negative 8x divided by 4, I got negative 2x. 4y divided by 4, I got y. Negative 28 divided by 4, I got negative 7. Although I could have divided both sides by 4, I decided only to divide by 2 because these 2 will go away. 4x divided by 2, 2x. Negative 4y divided by 2, negative 2y. 4 divided by 2, 2. And when I add the equations, these 2 go away. Negative 2y plus y is negative y. Negative 7 plus 2 is negative 5. Multiplying both sides by negative 1 gives us y equals 5. And then I go back anywhere. It doesn't matter where you go back. With y equals 5. So 4x minus 20 equals 4. I move 20 to the other side. I get 24 over 4, which is 6. So the point I determined is 6, 5. Is this okay with everyone? Did anyone else get 6, 5?
I got that as well in my homework.
Okay, perfect. Now I have to find pxx. So this is px. I have to divide it with respect to x. No x, no x. So it's negative 8. Pxy. No y, no y. So it's 4. And then I have to differentiate pyy. So py with respect to y is negative 4. No y, no y. Negative 4. At this point, I'm conducting the test, which says pxx, I cannot plug in anything. I should plug in 6 and 5, but there is nothing I can plug in. So it's simply negative 8. Pyy minus pxy squared. So this is a positive number. This is 16 with minus in front. So whatever this is, I don't even need it. I don't need to calculate this. I just need to know whether it's positive or negative. Because it's positive, the test is applicable. Because pxx is negative, the test is positive, d is positive, and fxx is negative. This is typical for a relative max. Now, what is the relative max? I have to plug it in. So I go back to the problem, to all this long thing, and I plug in 6, 5. So let's see if I made an error there. Negative 4 times 36 plus 4 times x times y, which is 30, minus 2 times 25, plus 28 times x, which is 6, minus 4 times 5, which is y, and plus 3. So when I calculated this, I got 77,000. So it's 77, but it's, so the relative max is obtained when 6,000 units of labor and 5,000 units of capital or something, or what was it? No, it was x and y. I didn't write down what x and y represent, but they were both units. So should I check this number? Let me check the number. So negative 4 times, did anyone get 77? Or should I check? Plus 4 times 30 minus 50 plus 28 times 6 minus 20 and plus 3. I did get 77. Any questions? Is this okay? Any questions on this? Okay, so we can say that we did talk about the d-test. Anything else you would like to go back to? Any of the problems?
Can we do the average function in chapter 4?
Yes. Very good. So let's take a look. So we have, let's say I'm making up a problem. So let's say we have f of x equals x squared plus 3x. And the given interval, let's say, is 2, 4. So we're asked to find f average on the interval 2, 4. That is by definition 1 over 4 minus 2, the integral from 2 to 4 from x squared plus 3x dx. So then, next step, we have 1/2 in front, and now the antiderivative, x to the third over 3 plus 3x squared over 2, everything from 2 to 4. So I will plug in 4 and subtract when I plug in 2. So 1/2, 4 to the third power, check my number, 16 times 4, I think it's still 64 today, plus 3/2 times 16, minus, when I plug in 2, 8/3, and minus 4 over 2 is 2, minus 6. So on the test, when you are calculating a definite integral like this one, all I wanted you to do is just plug in the numbers like you see here. You can even leave it alone. I don't want you to spend time on simplifying arithmetic. You can go back to the original and get the number with the graphing calculator. If this is correct, you get 100% for the problem. I don't want you to spend time adding, because this can be done with a calculator, and I don't want you to, I have to finish it. I will not leave it like that during class time. I can't do that. But what I'm saying is, during the test, don't spend time continuing this. If this is correct, you get 100%. Okay, I have a 64 over 3. I have a 24. I have minus 8/3 and minus 6. 64 minus 8, 56 over 3. 24 minus 6 is 18. Okay, so then 1/2, I have 56 plus 3 times 18 divided by 3. So this will be over 6. And again, I don't care about these calculations at the end, but I cannot leave it as is. I'll simplify by 2, and I have 55 over 3. These calculations can be cumbersome, and I know you can add. If you don't know how to add fractions at this point, you will do it with a calculator, so I'm not worried about that. Any questions on this?
Where did the 1/2 come from?
1 over b minus a, the integral from a to b from f of x dx.
Okay.
So f average is 1 over b minus a, the integral from a to b from f of x dx. Very good. Perfect. Next one.
Professor, can we do an approximation on the area of the graph?
Absolutely.
I don't have one. I can find one though if you want me to.
You can, or I can.
I'll leave that up to you.
And if you have one, I'd rather work on it.
I don't have one pulled up.
Okay.
So you can make it up.
Yep, I can. So
Thank
something like the integral from let's say 1 to 5 from e to x squared dx. Don't even try to find this exact. You will not be able to find the antiderivative, the function whose derivative is this. You cannot. So let's say we want 4 subintervals. And you tell me if you want the leftmost point or the rightmost point or the midpoint. We didn't really do problems with the midpoint. It doesn't matter. You can choose a left or right.
Is the midpoint going to be on the test?
No, we didn't. So we have other methods. No, we didn't do the midpoint in class. So no.
Okay, let's do the rightmost.
The rightmost point. Okay. Okay, so for the rightmost point, the first step must be illustrating the interval between 1 and 5. The next step must be delta x. 5 minus 1 over 4. 5 minus 1 over 4 is 1. 2, 3, 4. We chose the right. I have to use this point. I have to use this point for the height, this point for the height, and this point for the height. If you had said left, I would have used this point for the height, this point for the height, this point for the height, and this point for the height. Do not move on. Remember, you have only 4 subintervals. If you use all of them, I can give credit. I can say my student doesn't understand what we're trying to do. So if it says right, you have to use 4 subintervals. 1 with the height, the next one with the height, the next one with its height, and the next one with its height. That's it. Good. So then I'll say this is approximately. Approximately delta x outside, because that's a constant. Delta x is 1. I don't even need to put it in. F of 2 plus f of 3 plus f of 4, because we chose right, plus f of 5. At this point, I stop and I go to the graphing calculator and put these numbers in stats, edit, clear everything you have in there. And put in 2, 3, 4, 5. These are the x values. And then careful now. This is very important. Since delta x is 1, I'm not going to need it. But now I have to put in second and e to a power. And in parentheses, the power is the list L1, which has to be squared and close. In other words, the calculator will perform e to x squared when x is 2 and put it here, e to x squared when x is 3 and put it here, and of course the numbers will get large. This is 7.2 times 10 to the 10th power. Okay, huge numbers. Okay, now I get out of there. I know my numbers are in list L2. I go to calculations, 1 variable stats. No, I don't want list L1. No, my numbers are in list L2. And I want to calculate. And the only thing that I'm interested from all this bunch is just the sum of those values in list L2. And it's huge. 7.2, read all the number, please, till the end, times 10 to the 10th power. So 7.20 times 10 to the 10th. Humongous. It's because of the function and its power being squared. Don't look at anything else. You don't need the mean, you don't need the sum of x squared, you don't need the standard deviation or the standard deviation for the population. Nothing else matters here, just your summation, so that I don't have to do it by hand. Can you do it by hand? Sure. Just add those numbers, but it will not be very easy with such numbers, huge numbers. So that's why I recommend this step. So this is it. Is this exact? Oh, of course not. It's a gross misrepresentation because I only used 4 subintervals. Can I determine this exactly? Yes, with a calculator. Let's see how far we are. I'm just curious now since you asked this. We should be quite far because it's only 4 subintervals. The calculator does infinitely many subintervals. Okay, so math and number 9, I think it is, yes. Okay, so from 1 to 5. But you cannot use this for the approximation. You have to determine the way we did it together. So E, yes, and in parentheses I have x squared. I don't even think that, maybe it cannot even do it. We'll see if it does. Maybe, maybe not. It may give us an error. I don't know. Always remember, when we are looking at the definite integral, make sure that this function is continuous on the interval 1, 5. Otherwise, we're not going to get an answer. So let's see what it does and how long it takes. Okay, so 3, 3. Yes, so we got 7 point. Okay, we got 7.2 and they got 7.3, but 7.3, the difference between 7.2 and 7.3 is 3, so it's 154,153,746 difference. It's over 100 million in difference. So, and this is the exact. Of course, we got only 4 with using 4 subintervals. We are far from the truth, but we have an idea. And always remember when you try something like this, I'm going to make an error now, let's say between -2 and 5, and put 1 over x in here. 1 divided by x dx. What is the problem with this? Anyone? What is the problem with this?